In this lesson, we will explore inventory for service-based operations, an area of inventory management that focuses on managing the materials, supplies, and spare parts necessary to deliver high-quality services efficiently. While services are intangible, most service organizations depend on physical inventory to support their operations, from maintenance and hospitality to healthcare and information technology. Unlike manufacturing or retail, where inventory is directly tied to product sales, in service-based industries, inventory supports the performance and reliability of the service itself. This makes inventory control both strategic and operationally critical. Managing it effectively ensures timely service delivery, minimizes downtime, and enhances customer satisfaction. Service inventory typically includes consumables, spare parts, tools, and support materials. For example, a hotel maintains inventory of linens, toiletries, and food supplies. A hospital stocks medical disposables and equipment parts. An IT company may hold servers, cables, and replacement components for client support. In all these cases, the goal is the same: to have the right materials available when needed without excessive carrying costs. Demand forecasting in service-based operations can be more complex than in product-based businesses. Demand often depends on service usage rates, maintenance schedules, and unpredictable customer requests. Data analytics and historical usage patterns play an important role in anticipating demand accurately. For instance, preventive maintenance schedules help predict spare part needs before failures occur, reducing emergency purchases and downtime. Classification techniques such as ABC and VED analysis help prioritize service inventory management. High-value or critical items that directly affect service delivery are closely monitored and stocked securely. Less critical or low-value items can be ordered as needed. This targeted approach ensures that resources are allocated efficiently. Inventory control systems in service operations must also track item condition and usability. For example, tools used in field service may require calibration or inspection after each use. Automated tracking through barcode or RFID technology ensures accountability, reduces losses, and provides real-time visibility across multiple service sites. Service level agreements, or SLAs, often define performance targets that inventory must support. For example, in technical support or utilities, companies must guarantee repair times or response times. To meet these SLAs, organizations strategically position spare parts at regional hubs or service centers to enable quick access and minimize delays. Collaboration with suppliers is another critical factor. Vendor-managed inventory, VMI, and consignment stock arrangements allow suppliers to maintain key service parts on behalf of the service provider. This reduces administrative work and ensures availability without overstocking. Technology plays a transformative role in managing service-based inventory. Modern asset management and enterprise resource planning (ERP) systems integrate service scheduling, asset tracking, and inventory control into one platform. Artificial intelligence and predictive analytics enhance planning by forecasting failures or usage patterns, allowing preemptive stocking decisions. Performance measurement is essential for continuous improvement. Metrics such as service part fill rate, response time, inventory turnover, and downtime cost help assess how well inventory supports operational performance. Regular audits and reviews ensure alignment between inventory levels and service demand. In summary, inventory management for service-based operations focuses on ensuring that essential materials and parts are always available to support uninterrupted service delivery. By leveraging data-driven forecasting, supplier collaboration, and modern technology, service organizations can reduce costs, enhance reliability, and maintain superior customer satisfaction, all while operating efficiently in a dynamic environment.